Okay, that's the theorem. Okay, so let me review a little bit. Okay, maybe from here. Okay, I hope you remember the geometric series. Okay, so geometric series start by having a series of a sequence that have relations with a ratio. Okay, ratio is we multiply each sequence by this ratio. Okay, and we have these relations, and then we can conclude the Sn and Rsn, and then see the relations, and we have now this formula. Okay, and then we can conclude when the formula becomes converged and when the formula becomes diverges. Okay, it depends on R. Okay, depends on R. And actually, you can see if you are seeing this part here, 1 minus R. If it is a fractions, then it's actually makes sense. It's logical, right? If it is bigger than 1, it will be a negative. So it's kind of not making any sense, right? So you can also think from that point of view. Okay. And then we are moving to the test for divergence. But before the test for divergence, we are having this important theorem. If the series of an is convergent, then the sequence, the limit of the sequence is 0. Okay, that's important thing. Now the test for divergence. I will move here, or let me write divergence test. So if limit doesn't exist, or limit is not equal 0. Okay, so we start from the sequence. Okay, we start from the sequence, and then we can just conclude then series is divergent directly, okay, without any further information. So if we decide at the very beginning, okay, the limit is not 0 or it doesn't exist, then we can conclude the series is divergent directly. Okay, this is the easiest method to test whether the series is divergent or not. Okay, but if it's 0, it's converged, and you need to use another method to find maybe. Okay, and in the next sections, 11.345, all the sections will discussing about the method, okay, how to tell the series whether it's converged or diverged. Okay, this is one way we can do. It's called the divergence test. And maybe I'm giving you the example. So the example is if you have the series okay, since you can find, okay, you can find limit, and you can directly see from the n squared is 1 over 5, right? You can directly uh, show that this is 1 over 5. So you can directly say that the series, you can write all the information, is divergent directly. Okay. So you need to distinguish, okay, between the sequence, okay, and the series. The sequence is converged, but the series is diverged. Okay. 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 Another example, not really divergent test, but maybe example for ending these sections. So find sum of series plus 1. Okay. So 3 over n and n plus 1. And then the whole thing plus 1 over 2 with the power of n. Okay. So again, in the series, sometimes you will have more than one sequence or series. Okay. And then you need to, if you can find out what that is, you can separate them and use each method. I think this one, the left one, we already did with telescoping sum, right? So this just 3 multiplied by 1. Okay. You can, or you can write down the telescoping sum and then multiply all by 3, and it's 3. And here is what? Is the geometric, right? Geometric sum. So you can use the geometric formula. So I can write this as this part is 1, right? And this part is, let me write all the thing here, and then equal. Because it's geometric series, the first term is 1 over 2. The ratio is 1 over 2, and it's 1. So it's become 3 plus 1, it's 4. Okay. Just a few examples that sometimes we can combine the series into one big series. Okay. Okay. Now I can move to uh, maybe reviewing the chapter plan. Okay. Any questions first? Any questions? No? Okay. Let's move to the review. Okay. So maybe I will just go directly to exercise. Okay. Exercise. Okay, find the region, find the area, chapter 10. of region that lies inside both curves. Number one is R1 plus cos theta and R1 minus cos theta. Let me give you two questions first. And the R squared 2 sine 2 theta and R equal 1. Okay, try these two questions, and if you finish maybe only one, you can raise your hand and let me see your works. Maybe giving you around 5 to 10 minutes. You okay? You tired? Okay. First thing, if I'm giving you these two questions, can you draw? Okay. I think these two is in polar. They are not too complicated. It's not combination of two or more polar curves. So, like for example, these two parts is the cardioid because you have one and one, right? So your graph should be like a heart, but the positive one is going there, and the negative one is here. The large part is here, right? And if you have r squared and then something here and then 2 theta here, you will have the lemniscate, right? But because it's sine, it should be like infinity, but because it's sine, you need to rotate a little bit 45 degree, right? Okay. So at least, okay, try uh, to catch up with the sketching the curve, at least the simple polar curves, okay, the simple polar curves. I attached some videos for you last. I forgot, and the two previous Moodle in the bulletin board. You can check the video how to graph the polar curves. Okay, that's all the information for polar curves, like how to draw the limison. And there are at least 4 types of limison. You have the inner loop, you have the cardioid, you have the dimpled limison, you have the convex limison. Okay, and you have the lemniscate, and you have the rose curves, and of course you have the circle. Right. Uh, that's all the simple polar curves. Okay. The advanced one, or the more complex, is if you combine. Okay, like for example, like this one. If you're making two theta or 3 theta, it will combine with the rose curves, right? And if that's happened in your exam, I will draw the graph for you. Okay. But for the simple one, I hope you can draw. Okay, and try uh, to sketch the curves. Okay. So anyone finish the first one? Which one? Okay. What you get? Okay. Even between two of you, different answer. You get number one. Okay. You get it. Okay. Okay. Maybe let me draw first to help. And remember, when you draw, and if you see any symmetry, I'm suggesting to use the symmetry in your calculations to simplify the answer. So this will be okay. Suppose that the first cardioid and the second one is it's different. I suppose this should be the same length, but yeah. Okay. And the area is here, right? Okay. Now, because it's symmetry, uh, you can use this 1 plus cos theta or 1 minus cos theta. Okay. And what I want to do is, it will be 1, 2, 3, 4, right? 4 area. So you can choose this or this, but I think I will choose this one, the red one here, from 0 to here, pi over 2. So first is the area integration from, or maybe I will write 4 in front. So you need to multiply by 4 from 0 to pi over 2. And then remember the formula is the sector. Let me remind you the formula here. Say this is theta 1, theta 2. So the red one is 1 minus cos theta half. And then square theta. Let me use different color. It's become 2. And then this will be 1 minus 2 cosine theta plus cos squared theta. Theta. And then the cos squared, we can use the double angle formula. And then d theta here. Okay. Let's compute this to 3 over 2 minus 2 cos theta plus cos 2 theta over 2. Then d theta. I think we can integrate all. So a 2 3 over 2 theta plus, wait, it's minus 2, minus 4. Or maybe I will just go directly multiply, and it will be 3 theta minus 4 sine theta plus sine 2 theta over 2, right? And then from 0 to pi. And because it's sine, so we can ignore the 0, and we can compute the pi over 2. Yeah, this is the area. Okay. Okay, so the key in polar, if you find the symmetry, you can divide the area, usually by 2 or by 4, depends on how the curves looks like. And then you can just evaluate the small area and then multiply with the others. Okay. Okay, that's for the first one, the cardio, right? The second one, it's the lemniscates. R squared equal 2. Okay, 2 sine 2 theta. Okay, so it will be, let me draw to help drawing this, we can use this slide. Okay. Yeah, suppose this is the lemniscate. Okay. And the lemniscate is 2. So this will be 2. Okay. The line. So the circle will be in the middle. Maybe bigger. Maybe, yeah, maybe like that. And the area is here. And again, you can use the symmetry. Okay. And I think to make your calculation simple, I'm suggesting focus on the first quadrant. Okay? Always focus on this one, okay? If you find the symmetry. And you can find from this intersections until this. And then multiply by 4. Okay. So first, after you draw, you find, okay, this symmetry. You find the intersection here. Okay. From here to here, you find the intersections, and you will find the middle one. And you can integrate here from here, and then multiply by 4. Okay. But actually, sometimes in polar, depends on how you look the curves. Sometimes you can be having more calculations, like you have options, but it should be the same area. Okay? So first is, oh wait, the circle is 1, right? Yeah, the circle is 1. Okay. Now, to find the intersection, we can just equaling both of the lemniscate and circle. So 1 or 2 sine 2 theta is equal 1. So sine 2 theta equal half. So theta is 5 over 12. And then we can look at our area here. It's a combination between the circle and the lemniscate. Yeah. So first, we can plus the circle and the lemniscate. So let me write the equations. So area is 4. Okay. It's from 0 to pi over 12. It's half 2 sine 2 theta because it's already r squared, right? This is the lemniscate. Maybe I will mark this to show you know that this is pi over 12. And then plus, wait, maybe I get down. And then plus the integration from pi over 12, because this is pi over 2. So this should be pi over 4, right? So this really small part here is the lemniscate. And the pizza part here is the circle. Okay, got it? So you need to plus this lemniscate and the circle. And then it's just 1 squared d theta. This from pi over 12 until pi over 4. And now what we need to do is just calculate all these equations. Okay. So if I make it bigger, the area is actually this, and you have this. Okay. This part is the lemniscate. This part is the circle. If I'm zoom in, okay, if I zoom in. So yeah, the way you draw, you need to be careful, okay? Because sometimes if you draw maybe too small, like I think my drawing here is too small. So this part is kind of not really distinguishable. You cannot really see here, right? The bottom part here. But it's actually this the lemniscate. So if we zoom in, make it larger, we will see like this one. This one is the circle, and this one is this lemniscate. Okay, so that you need to be careful. Okay? Sometimes if you are drawing maybe not too clear, you will missing the small parts. Okay, that's also what I sometimes I did. And okay, what's missing? Okay, oh, the small part. Okay, okay, so that's need to be careful. So actually, all the calculations here, the integrations, it's not too difficult. The difficult part is the first identification, how to identify the problems, how to see which the angle and how uh, to draw. That's actually I think the most difficult one. The calculation is I think it's not too difficult here. It's just you can integrate directly, right? And just calculating the angle. So but let me just write the answer for um, I can just directly wait, maybe just writing half theta, and it start from 5/12. Sine 2 theta becomes negative, negative cos 2 theta divided by 2, and then 0, 5/2, 12, plus 5/12, 5/6 is what? Cos 30 is what? Right? Or let me just multiply by 4, it becomes negative. And then minus, plus, half, right? And multiply by 4 is 2. And then plus 5/12 for 5/3, right? Is that correct? Is my answer correct? Correct, right? Correct, correct. Yeah. Yeah, I didn't really write down all the steps. Okay. So yeah, I think you can do it, right? The integration. It's not too difficult. Okay. Okay, maybe giving you another review. Um, maybe to make sure you get the idea, I'm giving you another one. Uh, so find the area of region that lies inside. Uh, let me write the first curve and outside second curve. Let me write the curve is the first curve R uh, 2 plus sine theta and R 3 sine theta. So this A and maybe B. Okay, I think B is more easy, so you can start from B first if you want. Yeah, it's because it's similar to the previous one, the cardio. The number A is 2 plus sine theta. So this 2 is greater than this 1, right? So it's not the cardioid, it's not the inner loop limation, it's the other one. Okay, it's the convex limation. Now let me give you some minutes, maybe 5 to 10 minutes to try and solve. So I'm giving you all the polar because I know polar is relatively more difficult than the Cartesian because you need to familiarize with the system, right? You need to change your perspective of view from the rectangular coordinate to polar coordinate, and it is really different. Okay. This one? Oh, from the book, right? Yeah, from here. Number one, really? I think this part should be intersect the circle. As you know, you can actually see 2 plus sine. Find maximum is in pi over 2, right? It's 3, right? Right? That's how you draw clearly. Okay. Uh, my suggestions. Okay. Every time you see the polar curves, you can imagine the maximum value. Okay. For example, 2 plus sine. Uh, this one, you have the maximum value when sine is pi over 2, right? When sine is pi over 2, it's 3. So when you see the circle is having also 3 sine theta, so it should be intertwined, right? It has intersection at point at radius 3, right? And also same thing here. You can also see what's the maximum value for sine. Okay. So when you draw, you can check at least check 0 and check pi over 2. Okay. That's the easiest one you can check. Okay. If you like, maybe you're not really understand the pattern, like how to draw, you can just check the easy angle to see how the graphs looks like. Okay. Number B is more easy. You can check B. Oh, it's okay. No. Oh, yeah. Hmm? Yes. Hmm. Mm, yeah, you can see from here. You can use the cardio, right? You can the cardio is here, right? Yeah, it should be minus. Yeah, yeah. So the cardio will be here, right? Mm, yeah. Number B, you got it? Yeah, I think. You get it? Okay. Which part? The number one or two? Both. Okay. Okay. I think for to help you maybe exercise more, I'm giving you the next in the next Moodle. I'm giving you the graph for several curves. Okay. And let me start with number B. Okay. Because it's more uh, doable. Okay. Okay. Let's see from here. Previously, we done the 1 plus cosine, right? If you have 1 plus cosine, you will have the cardioid facing the right side, right? If you have sine, first 1 plus sine. Plus means facing up, okay? So your cardioid will be like that. And if you have minus, you need to mirror that, okay? So you will have, let me use the other color. You'll have, okay. And then the clue, how to graph, okay? You have 1 and 1, 1, right? A is 1, B is 1, okay? This should be 2. This should be 1. This should be 1, okay? The distance. So when you draw the circle 1, so it should be intersect at this point. That's the clue for the cardio, okay? Actually, you can see the video that I attached in the previous model, how to draw the polar curves. And from here, actually, you can find if you have uh, A and this is B, if A is equal B equal 1, that's the cardioid, right? If A is less than B, it's the inner loop dimension. If A is greater than B, it's dimple dimension. And if A is greater to B or equal to B, it's convex dimension. Okay. So meaning, like I told you before, uh, if this is cardioid like this, if you're getting smaller, like A less than B, for example, maybe A is 1, maybe B is 2, you will have the inner loop. And the inner loop will be the difference between AB. So it's the distance should be 1 if that's 1 and 2. Okay. And dimple dimeson, it's similar to cardioid, but it's having like that, not particular in the 0 here. Okay. And convex, it's not dimpled, but uh, it's like a straight line, and then so it's like getting more and more like circle when you have bigger A. Okay, so from here, let me continue to draw the circle. Yeah, I think that the circle. The questions is what the question? Inside the first curve, but outside the second curve. The first curve is the cardioid, so inside the cardioid, but outside the circle. So it should be here, this the bottom part. Okay. So the area is this. Okay. Or if you want to make sure or write down all the point, maybe point in here is 1 and 0, or 1, 2 pi also okay. This is 1 and pi. Or we can, if you want to write down the intersections, that's also fine. We can prove that, and we can look for the area will be because we are going to go from here to here, then I will select the pi to 2 pi. Okay. So it will be the integration from pi to pi. The whole, oh, wait, half, and then 1 minus sine, and then minus 1. Okay, okay, you get it? So from this pi until 2 pi, you need to subtract the cardioid and subtract with the circle. Okay. Yeah. And then it's 1 to sine theta plus sine squared theta. And use the double angle formula, factorize half. Okay. And then we can integrate this. It will be theta minus sine to theta over 2 plus 4 cos theta 1 over 4 from pi to pi. And then you get that this is actually pi over 4 plus 2 when you plug in. Okay. But I hope the calculation part is understandable because it's just regular integration and using some double angle formula. Okay. So most of the parts in the in 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 the area when you are dealing with the formula for polar, most of the time you will just using the double angle and then just integrate. Not too really difficult. The difficult thing is to identify the problem. Okay. The sketching, the angle, finding that's more more difficult. Okay. Number A, right? Number A. Okay. Let me write number A. Number A. Let me write the equations: 2 plus sine and R. Okay. First, we need to draw this, and remember it's 2 plus sine, and now it's 2. Okay. A is 2 and B is 1. So A is greater than B, and because A greater than B, it's a dimple dimeson. Okay. Yeah, it should be symmetrical, but okay. And the circle will be here. Yeah, it should be symmetrical. So inside the first curve and outside the first curve. Okay. Now from the picture itself, we can see that the point is 3 and the pi/2, the polar coordinate. This is 2 plus sine, and inside is the what is 3 sine. Okay. Actually, this is not too difficult. What you need to do, you can calculate total area here. It's actually area of this limason, right? So you can use integrations from 0 to 2 pi, and you get the total, right? And then the area inside is just a circle. The radius is 3/2. Just minus that, right? Okay, easy. It seems smiling, but seems like smile with shocking. Okay, so let me write the general area. Half 2 plus sine, or let me write area total and area of circle. Area of circle is just pi, and then 3/2 squared, and then minus this, and this is the answer. Okay, and you can solve that. Okay, make sense? Okay, so for because the circle is totally inside, so you can just calculate total area minus the circle, and the circle is from the picture, because the diameter is 3, so the radius is 3/2, and you can just use the circle formula to find the area, and that's the calculations. Uh, the answer should be 9/4 pi, but you can check. Okay, you can check. Okay. Any questions? Okay. I will attach this part notes and notes from chapter 10 into your Moodle, so you can review, and maybe tomorrow you can also review with your TA. Okay, okay, later we can discuss. Okay. Okay. Any questions? I think I can finish until here. Uh, anyway, what I can suggest is familiarize with the polar curves. Okay? How to draw the polar. Okay. Okay. I think that's it for today.